All right, so combining some stuff we learned earlier with some new stuff, let's take a look at this scenario right here. So we have sodium chloride as a solid, and then we're going to dissolve it in some water. And so sodium chloride is an electrolyte, and so it will dissociate into sodium plus and chloride minus. And so the question here is, does NaCl count as one solute particle or two solute particles, right? On the left here, it looks like it's one thing, but then on the right, it looks like it's two things. So what's the truth? And the truth is it kind of depends. As always, it's not that simple. But overall, it's going to be closer to 2. And so let's take a look at that. So what this is known as is the Vant-Hoff factor. So Vant-Hoff factor. Very cool name, not that cool of a discovery. It gets the symbol I, so that's the Vant-Hoff factor. And the Vant-Hoff factor is a measure of how many solute particles are there per formula unit. So if you have a non-electrolyte, right, something that doesn't dissociate, you would predict that it would have a Vant-Hoff factor of 1, right? Each sugar molecule is going to act as one sugar molecule. If you have something like sodium chloride, you would predict that it would dissociate into two things, and so you'd predict a Vant-Hoff factor of about 2. Something like magnesium chloride, you have 3 particles here, right? 1 magnesium, 2 chlorides, so you'd predict the I would be 3. And so here's a picture of this, or my bad, a table of some data here. And you can see overall these predictions are pretty good, right? Glucose, right here's the measured, here's the predicted, right? They match really nice and well. Something like sodium chloride, you'd predict 2, but really it's only 1.9. And then you can kind of see so on and so forth, right? This one's, 2 and 1.9 again. And then we have some kind of variations, 2 and 1.3. Down here, iron chloride, right? You'd predict 4, but really it's 3.4 when you actually measure it. And so naturally a question is, why is the I of sodium chloride, the Vant-Hoff factor of sodium chloride, not equal to 2 exactly, right? It should dissociate into sodium and it should dissociate into chloride. So why doesn't it count as 2? And that's because of something called ion pairing, right? And so basically, even though you dissolve this, some solvated particles still pair up and thus only count as 1. So here's a picture showing this ion pairing. So you can see some sets of potassium chloride have completely separated, so those would indeed count as 2 particles. However, some are paired up in these ion pairs, and so they only count as 1 particle. And so why does this occur? Well, a lot of it is due to the concentration. Right? In order for the solvent to dissolve this stuff, you see it's got to be surrounded by multiple different solvent particles. And so as you increase your concentration, you start running out of particles or solvent particles to solvate your solute. And so you'd see a decrease in the value of I. So for example, in this table, that this is for 0.05 molal aqueous solution. So if we increase the concentrations, the value of these I's would drop, or if we diluted these concentrations, their values would increase, right? And so when you increase the concentration, you essentially run out of solvent particles to effectively separate these ions.